So we're going to do a quick refresher of graphing linear functions. So remember slope-intercept form. M stands for your slope and B stands for your y-intercept. A family of functions is a group of functions that have similar characteristics. Like I could have a bunch of different linear functions. They're all straight lines. They might have different slopes, y-intercepts, but they're in general kind of similar. Or I could have a family of quadratic functions that also kind of share similar characteristics. So those are different families of functions. In a family of functions, your parent function is the simplest function. So for your linear functions, it's just y equals x or f of x equals x. So looking at a couple of these, if you have y equals 2x, we want to state its slope and y-intercept. Sometimes it helps a little bit if your y-intercept isn't written there to think of this as 2x plus 0. Your slope's your coefficient on your input variable x, so it's 2, and your y-intercept is 0. Or a lot of times we like to write intercepts as points, so it's the point 0, 0. If you graph it, you want to graph your y-intercept first, so cross the y-axis at 0, and then your slope is 2. So think of it as rise over run. It needs to go up 2 and to the right 1. Since it's positive 2, I could go in the up direction, right direction, or I could go down in the negative direction and left in the negative direction, because that would still give me a slope of positive 2 if I divide negative 2 by negative 1. And then draw in some more points following that same pattern, connect it. You should have arrows on both ends of your line because it does continue forever and ever. And now if I'm comparing that to my parent function, y equals x, I'm going to sketch it in pink here. So there are a variety of things we could say if we were going to compare those two. We could talk about the slope, we could talk about the y-intercept. I'm going to say that y equals 2x is a steeper line, or it has a larger slope than your parent function, and they have the same y-intercept. Let's look at another one. So this one is kind of in a different order than you might expect. If it bothers you, you can rearrange it. So if you look at your slope, it's your coefficient on your variable. So that is going to be negative 3 over 2. And your y-intercept is the value that's being added or subtracted. So it's negative 2. Like I said, if it makes you feel better to rearrange it into the form you're more used to, go for it. And then graph it, start at your y-intercept of negative 2. And then your slope is negative 3/2. So I'm going to go down 3 and to the right 2, draw my next point. Won't fit if I keep going that direction, so I'm going to go up 3 to the left 2, draw my next point. And I'm going to connect those points and erase some of my mess. And then I am going to let you guys do some comparison about what you notice between it and your parent function. Let's think about a couple of special kinds of linear functions. So if you have y equals some number, say you have y equals 2, that means that it consists of all the points that have y values of 2. So if I sketch all those points and connect them, they make a horizontal line. If you think about x equals some number, that consists of all of the points that have that set x value. So say I pick x equals negative 1. If I sketch all the points with an x value of negative 1, it's going to form this continuous vertical line. So x equals some number is the equation of a vertical line. If you forget, just start sketching some points and connect them and you can see what type of line it makes. So on this one, it's x equals 4, which means that it consists of all of the points that have x values of 4. So like 4, 1, 4, 3. It is a vertical line. And if I'm thinking about domain and range, your domain, your x-coordinates, the only one you have is just 4, and your range goes from negative infinity to infinity, up and down forever and ever. Sometimes you want the x and y intercepts of a line, which are the points where it crosses your x or y axis. You can get them without graphing or rearranging and putting in slope-intercept form. So think about what you know about your x and y-intercept points. If you're thinking about the x-intercept, you know that the y-coordinate of that point is going to be 0. And if you're thinking about the y-intercept, you know the x-coordinate is going to be 0. So let's just plug those in and find them. So looking for the x-intercept of this function, I know my y-coordinate is going to be 0, so if I plug 0 in for y, 3 times 0 is going to give me 0, and then I can solve that equation for the x value where it'll cross the x-axis at. So my x-intercept is the point -3, 0. My y-intercept is pretty similar, except this time I know that my x-coordinate is 0. You can also think about, well, if I plug in 0 for x, that's going to leave me with y, so it'll leave me with my y-intercept. If I solve this one, I end up with a y-intercept of 2, so it's going to cross at 0, 2. So if I erase those ones that I just kind of threw up there and put my actual x and y-intercepts, I can graph my line. I could do some additional points kind of following that same pattern with the same slope so that it makes it a little bit straighter, and sketch it in. We're thinking about a car. So if you go out and buy a car, it's not gonna keep the same value that you bought it for. It's gonna lose some value each year because it gets older. It's not worth as much. So if I think about this car, it was worth $12,000 when I purchased it, and it's decreasing by $2,000 for every year. So after 2 years, it's going to be worth $12,000 minus $2,000 times the number of years I've owned it. My slope is my loss of value per year. So it's losing a value of $2,000 each year is what my slope represents in this situation. And my intercepts, think about my y-intercept is 12,000. That's the initial value of my car, what it was worth when I purchased it. If you think about where it would cross the x-axis after your value goes down, 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 and then reaches that point, that is when it has a value of $0. In all reality, this is probably not a linear function. It might be more exponential, but we're going to model it with the linear function. So if I graph that function, you have to think about what scale to use. Can I count by ones? No, it's not going to fit on my graph that I have. So I am going to count by 2000s on my axis. Make sure that you label what each of your axes is measuring, so that's in thousands of dollars. And then my x is the number of years after I purchased my car. Okay, so now that I've got it set up, let's graph it. My initial value, my y-intercept, was $12,000, and then it's decreasing at a rate of $2,000 per year. That's not 2 boxes, it's $2,000, which actually is only 1 square on my grid. So in 1 year, it loses $2,000 value. And then really my car's value can't go negative, so I'm gonna stop it right there. My domain and range. Domain is the number of years that I've owned it that makes sense in my function. So from 0 up to 6 years when my value reaches $0. My range, I need to write it from smallest to largest. My values go from 0 at the end to $12,000.